Okay, so moving on to question 2 on work for the study plan, chapter 2. Um, Question 2 says a car moving at a velocity of 20 meters per second is behind a truck moving at a constant velocity of 18 meters per second. When the car is 50 meters behind the front of the truck, the car accelerates uniformly at a 1.8 meters per second squared. The car continues at the same acceleration until it reaches a velocity of 25 meters per second, which is the legal speed limit. The car then continues at a constant velocity of 25 meters per second until it passes the front of the truck. The distance the car travels while accelerating in meters is closest to. Okay, so in this question, we're going to be using the same formula that we used in question 1, which is going to be V feet RV. What is this? Okay, so RV. No, okay, so I'm back. So let me just erase this. Okay, so we're going to be using the same formula as V squared equals V initial squared plus 2/8s. But they want the distance this time, so we're going to be solving for s. So this equation, once you rearrange the whole equation, you're going to have s equals v final squared minus v initial squared over 2a. So our final velocity, it says, let's see what it says. A car moving at a velocity of, so initially is moving at 20 meters per second. The initial velocity. The car is a female in the car with the car acceleration normally at 20 meters. The car continues at the same acceleration until it reaches the velocity of 20. So the final velocity is 25. So we're going to have 25 squared minus 20 squared over 2. Then we got to find the acceleration. Acceleration is 1.8. So 1.8. So when you do this math, you're going to get 625 minus 400 over 36. So the distance that the car travels once you subtract and divide by 36 will be 62.5 meters. So that comes out to be, if you round up, it's 63, but 63 is not one of the options, so it is 62. So letter C.